Yalimada, welcome to our primary webinar, Making Numbers Real. My name is Nura Musa and I am a primary Key Stage 1 phase leader and maths coordinator, and I've been working alongside the Al Khan Education Board in developing and supporting these primary webinars. I'm extremely pleased to introduce our speakers today, who between them have a great wealth of knowledge on the primary maths curriculum. Our first speaker is Seema Kara, who is an extremely experienced primary school teacher and Year 3 leader working in a primary school in Harrow. And our second speaker is Shalina Jawani, who is a primary STEM teacher. Shalina also runs Young Engineers in Northwest London. Her workshops include mathematics as part of STEM learning using Lego and building bricks. Before we start, I'd like to just go through some housekeeping rules. Please ensure you keep yourselves on mute as we are recording today's session to ensure that everyone gets the most out of it, and so we'd like to minimize any noise interruptions so everyone can listen to this. The aim of these webinars is to be as interactive as possible, and we'd love for you to communicate with us. So please, if you have any questions, please type them in the comments section below. And please make sure you state what age or what key stage your child is in, and our team will try and get back to answering your questions as soon as we can. Thank you. So today's webinar, we will be discussing common difficulties that children might encounter when learning maths, the key features of maths teaching in the primary curriculum, and in particular we'll be concentrating on the 4 operations: addition, subtraction, multiplication, and division. And hopefully this will support you with using these methods with teaching your child, helping your child at home, and give you some games and ideas that you can also use at home to support your child. The primary maths curriculum has 3 main aims, and it's broken down into the children should become fluent in the fundamentals of maths. And what we mean by fluent is fluent in number and fluent in the 4 operations of number with calculation. Once they are fluent, they can then use this to reason mathematically. They become confident with using mathematical language, that they can give reasons for how they got to an answer. They can argue why an answer is right or wrong using that knowledge, and that they can solve their problems and apply this to a variety of different problems. Talking about mathematical vocabulary, I can't stress how important a child's understanding of the vocabulary used in maths is important to helping them develop and use their thinking skills. They should be able to understand spoken and written instructions, because this will not only help them now, but in the future when it comes to their secondary schooling, when it comes to testing. They need to become familiar with the mathematical terms used. So when you are working at home with your child, please make sure that you do use these words. They become more confident and they become more used to these terminologies. And they should be able to understand that some maths terms have dual meanings, as the English languages can be confusing. And what do we mean by good practice in maths today? Today's maths is very different to what it was like when we were at school. When we were at school, we were expected to sit at a table, copy from a textbook. Maths is very different now. It's not just about getting the answers right, it's understanding how you got to that answer, what method you used, what worked for you. Did you understand the relationship with the numbers and the methods you used? To know that it's okay to use a different method to maybe what your friend is using, and to justify how you got to your answer. And the primary curriculum is broken down into 4 sections: number, measurement, geometry, and statistics. But again, today's session is talking about number, the importance of number, and how children should be able to use and apply this, and then apply it to other areas of the maths curriculum. And again, talking about using and applying maths, what do we mean? We mean that children should be able to use their knowledge of number and be secure in that they can represent their work using pictures, they can discuss what it is that they are working out, they can recognize relationships between numbers, they can discuss their work again using that mathematical language, they can use symbols, and most importantly, they can explain why their answer is correct and how they got to that answer. I will now hand you over to Seema, who will go into further detail. Thank you, Seema.
Thank you, Noreen. We're going to take a look at what we mean by fluency, having fluency through number sense, and why this is so important. So, taking a look at this slide here, it shows us that children need to start by having a very solid sense of number to be able to securely understand number and reason mathematically. So looking at phase 1, which is usually developed within the early years or the early parts of key stage 1, children are very much developing their counting strategies and their understanding of number as a value. So for example, using objects to count and verbally counting. So in the example that I'm going to give you today, the child starts by developing their understanding of that. They count 6 beads out, then they count 5 beads out, and then they count them all together as 11 beads. Once they feel secure in this, they're then moving on to developing their reasoning strategies. Reasoning strategies can develop straight from the early years, but they are built upon in the later parts of key stage 1 and the early parts of key stage 2. So it's using their known facts that they've developed through their early schooling, and then starting to establish relationships from what they know and what patterns they can see and what they've understanding about what their understanding about number is. So for example, well, I know that 5 plus 5 is 10. I've learnt that through my number bonds. And 6 is 1 more than 5. I've learnt that through my adding 1 more. So then 6 plus 5, so 6 plus 5 must be 11 because that's 1 more than 10. Looking further on into phase 3, this is this is usually developed in the later parts of key stage 2 and beyond, and it's where children are becoming fast and they are becoming accurate with their calculations. So looking straight away at the calculations, 6 plus 5, the child will know that it is 11. And I can't stress enough how it's important that children very, very early on develop a strong number sense and have a really strong understanding of number through counting, through physical resources. Just like a house, you need strong foundations to be able to build on with the rest of your understanding of number. So we're going to take a look at the progression of addition through the primary curriculum and how each year builds upon the year before within primary schooling. So as a main theme throughout addition and subtraction as well in primary schooling, there's a very strong emphasis on place value, which I'm sure you can see from the slide. The word place value crops up a few times. Place value is extremely important right from early years and year 1. It's important that children have a very strong sense of place value, and that numbers aren't just numbers, they do hold a value. And once children have a strong understanding that numbers hold a value, the rest of the concepts like addition and subtraction and multiplication and division become much easier to embed. It's also important that children develop an understanding of the relationship between place value and addition, and that's what is built upon within the primary curriculum, as you can see. So for example, in year 1, the children are understanding the importance of number bonds and their place value of 1s and 10s, and then that is built upon. So then in year 2, we're looking at number bonds to 20 and then the place value to 1s, 10s and 100s, and once they've mastered this, they're then looking at the place value to thousands and beyond as well. It's very important that any gaps in your child's learning are plugged and filled in before moving your child on. So for example, if they haven't got their number bonds to 10, it's really important that they are strong and confident in their number bonds to 10 before moving on to number bonds to 20, and even looking at decimal points. Really, they need to have that strong foundations first. So this is how the progression of subtraction looks within the primary curriculum. Children need to be able to securely count on and backwards confidently, and this is something that is developed in the early years and year 1. Once children are very secure in counting backwards, it makes subtraction so much easier when using a range of methods, and some of these methods we will look at later on, particularly the number line method. If your child is secure in being able to count backwards, the number line method is a lot easier to use and pick up. As you can see, as children move through the primary curriculum, it's just basically about developing a range of methods within subtraction, and from the previous slide, addition. And it's having those methods, being able to use those methods confidently, but also being able to see which methods suit them and which methods they would like to use in their learning. So we're going to look at the fundamentals of number, addition and subtraction, and just the key areas that children will be learning within the various key stages, and what we feel that children should really have a secure understanding of within each key stage, and what would be great for you to work on with your child at home. So we're looking at key stage 1, which is years 1 and 2. These areas are related to number, addition and subtraction that children will be learning, and it provides, and this is really important, as I was talking about with the foundations in the house before, it's really important that children have a secure understanding of these areas first before they're moving on to their further learning. Key stage 1 is really about developing that secure understanding and foundations of number, addition and subtraction, and the rest of the schooling builds on. So here children are understanding that numbers can be represented in a variety of ways. They can be used as measures, as labels, and they're probably used to seeing this in their environment. It's really important children understand that number has a value, and that the number 1 in 18 isn't a 1, it is a 10, and then the 8 holds the value of the 8 ones. Children demonstrate adding as putting 2 objects together, and subtract as removing of an object. It's very important to make sure children understand this by doing adding and subtracting physically, and that's how they're going to be able to develop that concept and that understanding of exactly what addition and subtraction is. Don't be afraid to get resources out and use resources when adding and subtracting. Right up until year 6, children are using resources. It's nothing to shy away from. In fact, it will help your child to develop a deeper understanding of exactly what addition and subtraction is, and using resources for more complicated methods as well. Children should be very secure in using symbols in their number calculations, and I just want to stress that when you are doing number calculations, or number sentences as some schools call them, just please use either number calculations or number sentences with your child, and not a sum. The word sum actually means to add together. So if you have got a subtraction calculation in your child and you're saying please complete this sum, that can be confusing when looking at word problems later on in their curriculum. And also, just as a side note, equals can be used either side of a calculation, so it can be 10 equals 5 plus 5, or 5 plus 5 equals 10. And it's very important your child has a secure understanding of this, as from our experience we found that having the equals on either side of a calculation does crop up many times in SATs papers. So taking a look at the lower key stage 2, which is years 3 and 4, is now building on what children have learnt in key stage 1. So they have a very secure understanding of place value, and they're looking at place value up to hundreds and most likely even thousands as well. They're developing an increasing variety of methods to add and subtract, and again we will look at some of those methods a little bit later on. Children can show their calculations in a variety of ways, whether that's written as a calculation, drawn, or using the bar model, which we will look at later on as well. So here we have the number line method. This is a method that is taught in year 3 and used in year 4 as well. It's a method that a lot of children do find quite easy to use.
We're going to start by taking a look at the number line method. This is a method that is usually introduced in year 2 or year 3, and it's the starting point for looking at a range of methods for addition and subtraction. So let's take a look at the calculation. 22 plus 23, for example. The first thing that I would need to do is draw a number line, okay? Now I need to take a look at my numbers that I'm working with. I'm working with 22 and 23. So I'm going to start at 22. Now remember, you can start at 23 if you would like, because addition is commutative. It can be done in any order. So I'm going to start at 22. I need to look at what I'm adding on, 23. Now 23 has 3 ones and 2 tens. So I'm going to be doing 2 jumps of 10, 10, 20, and I can write plus 10 in there to remind me these are jumps of 10. So the children should be quite confident counting in jumps of 10 from any number. So this should be fairly simple. So 22 plus 10 is 32. 32 plus 10 is 42. Now we're going to take a look at doing the jumps of 1, of 3 ones. Now this can be done in 2 ways. You can do 1 jump of plus 3, or for those that are not so confident or are starting with the number line method, you can just simply do 3 1 jumps. So 42 plus 3 is 43, 44, 45, and that's how you get your answer. It can be used in the same way for subtraction. So if I'm perhaps looking at 55 take away 13, again I would start with my number line, but this time instead of starting here and going forward, I'm going to put 55 over here. And that's simply because when you're subtracting, you're going back, your number is decreasing. So I'm going to start at 55, and exactly the same way, I'm going to look at what I'm taking away. I'm taking away 13. So 13 has 1 10 and 3 ones. So 55, take away 1 jump of 10 is 45, then take away my 3 ones. And again, same as before, you can just do take away 3, or you can do 3 ones. Okay, so take away 1. So 45, take away 1 is 44, 43, and then 42, and then that's how we get our answer.
Other methods that children are taught in year 3 and 4 are the formal written method, which I'm sure many of us were taught when we were at school, and the expanded method as well, which is a method that, from my experience, I found that many children feel very comfortable using, and clearly shows how the tens and the ones in a calculation work together to create an answer. There are videos on these methods that will be available for you to view in the resources section, should you wish to view them. We are going to take a look at the bar model. So by now, children have a very secure sense of number. They are very good at using the expanded method, the formal written method, and they have a very deep understanding of what number is. The bar model, from my experience, I've used it within the early years, and I've used it all the way up to year 6. So we can take a look at the video. It's very important that children know what the bar model is.
We're going to take a look at the bar model. This is a model which is really effective when problem solving. So for this example, I've got a word problem here where I'm going to show you how I can use the bar model to solve. I have 5 red sweets and 4 yellow sweets. How many sweets do I have altogether? So, looking at the bar model, I can draw one bar to represent my 5 red sweets. I can draw another bar to represent my 4 yellow sweets. The size of the bar doesn't actually matter, it's just there to represent the number. So I've got 5 red sweets, 4 red sweets. How many sweets do I have altogether? So we've got 2 parts, the 5 red sweets, the 4 yellow sweets, and then the whole, which is them all together. So using my knowledge of number facts and addition, which I'm secure in, I've got 5 plus 4 equals 9. 9 sweets altogether. Now it's just really important to point out to you that when I started to draw my bars 5 and 4, I could see that it was an addition problem because I've got 5 plus my other bar, that's 4. I needed to put them together to get my whole. So I can clearly see that's an addition problem. Let's take a look at this problem over here. I have 20 sweets this time. 8 of them are blue and the rest are green. How many are green? So let's take a look at what information we do have. I have 20 sweets. That's my whole amount of sweets, 20. So this time we're not working out the whole, we already have the whole. So I have 20 sweets altogether. 8 of those sweets are blue. Okay, so looking at this model, this isn't an addition problem because I haven't got 2 parts and I'm working out a whole. I have the whole and I have one of the parts. So I can clearly see it's a subtraction problem because I need to subtract the 8 from the 20 to get my answer. So 20 take away 8 is 12. So my answer is 12. There are 12 green sweets.
So just to touch upon the bar model, it's very important to make sure your child knows the bar model, and it can be used widely within SATs papers and that sort of thing. It's a pictorial representation of number and it supports children's problem solving and their number fluency as well. So taking a look at upper key stage 2, which is years 5 and 6, children are now secure and fluent in addition and subtraction. They're able to use their knowledge of addition and subtraction to reason well about their answers and how they got to their answers. And they're now looking at problem solving in a variety of ways, looking at 2- and 3-step problems using the methods that they have learned through their primary curriculum.
Now take a look at exchanging with...
Sorry, I was just going to say we're going to take a quick look at the video on formal subtraction, and there's a very important note on exchanging.
Subtracting using the formal written method. So this is when you have your digit that you're starting with, which is smaller than what you're taking away. So for example, here we've got 176. Take away 47. So we've got 6 take away 7. Now subtraction is not commutative. You can't just swap the numbers round and do 7 take away 6. So you still have to do 6 take away 7, but that can't be done, so we're going to need to exchange. So what you're going to do is you're going to look at your tens and exchange the 7 tens for 6 tens and give one of those tens to your ones. So it's now 16 take away 7, which is 9. Okay, this is 6 tens now, not 7 tens anymore because we exchanged. 6 tens take away 4 tens, which is 2 tens or 20, and then we've just got our hundreds. So that would be 129.
So being secure in addition and subtraction is key for children to be able to understand multiplication and division. I'm now going to pass on to Shalina, who's going to talk about multiplication and division.
Thank you, Seema. Okay, Yalman everyone. Okay, so I'm going to go on to talking about multiplication and division now. So if we start with Key Stage 1, so that's years 1 and 2, children will be introduced to their times tables, so that's the 2s, the 5s and the 10s, and they should be able to recognise the difference between odd and even numbers. They should be able to write mathematical statements for multiplication and division using signs. So for example, 5 multiplied by 2 equals 10, or 10 divided by 2 equals 5. They should be able to solve problems using multiplication and division facts, and this can be done through a variety of ways. So firstly through arrays, which we'll have a look at in the next slide, through repeated addition, through mental methods, and through solving problems in context, so word problems as well. Okay, and during lower key stage 2, so that's years 3 and 4, by the end of year 4, children should have memorised their times table up to the 12s. They should be able to read and spell mathematical vocabulary correctly and confidently. Children should be able to make connections between fractions of a length. It could be a shape, a representation of a whole, or a set of quantities. And children should be able to use factors and multiples to recognise equivalent fractions and simplify where appropriate. So for example, 6 over 9 is the same as 2 over 3. And by the end of primary school, so by the end of year 6, children should be able to use common factors to simplify fractions. They should be able to compare and order fractions. They should be able to add and subtract fractions. They should be able to multiply simple pairs of proper fractions and write their answer in its simplest form. They should be able to associate a fraction with division and calculate decimal fraction equivalents. They should also be able to multiply and divide by numbers 10, 100 and 1,000, and we'll have a look at some examples in the slides ahead. They should be able to multiply 1-digit numbers with up to 2 decimal places by whole numbers. And finally, they should be able to recall and use equivalences between simple fractions, decimals and percentages. So we're going to have a look at a few different types of multiplication methods here. If we look at the example in section A, we can see in Key Stage 1, an example would be 4 multiplied by 3. So 2 different ways of working this out. Children can use the additional, repeated additional method. So that would be 3 plus 3 plus 3 plus 3. So 4 times, which is 12. Or you can use an array. So we're just going to watch a video here to explain exactly what an array is.
An array is formed by arranging a set of objects into rows and columns. Rows are along the page and columns are down the page. We can also use our arrays to show us how to do multiplication. Let's have a look at my cakes in front of us. First, I'm going to group my cakes into rows. This is my first row. And this is my second row. Now that I've done that, I can see that I have 2 groups, 1, 2, of 1, 2, 3, and 1, 2, 3. So I have 2 groups of 3 cakes each. So I've got 2 groups of 3 cakes each. Now that I know that, I can help write my multiplication sentence. So when I see this phrase, groups of or lots of, I know that that means the same as multiplication. So I can write my times symbol there. Then I can put the other numbers in. So I know that I have 2 groups of 1, 2, 3 cakes, and I'm going to write that in so I've got my full multiplication sentence. So I've got 2 times 3 equals to 6. And I can also say 2 multiplied by 3 equals to 6. If I really wanted to challenge myself, I could also think about how else I could write that number sentence. Does anyone have any ideas?
Okay, so moving on, now going on to lower key stage 2. So by the end of year 4, children should be able to multiply by 10, 100 and 1,000. So if we look at the first example, 34 multiplied by 10. Now we know we add a 0 onto the number, making it 340. But what's important is that children realise what's going on in that process. So what we do here is we move the digits one place to the left. So we place a 0 in the ones column. We have a 4 in the tens column. And we now have a 3 in the hundreds column. So making the whole number 340. In the next one, if we look at 72 multiplied by 100, so yes, we have added 2 zeros, but again, the digits have moved this time 2 places to the left. So we have a 0 in the ones column, a 0 in the tens column. The 2 is now in the hundreds column, making that 200, and a 7 in the thousandth column, representing 7,000, making the whole number 7,200. And then finally, 18 multiplied by 1,000. So we've added 3 zeros this time. We've moved the digits 3 places to the left. So we have a 0 in the ones column, a 0 in the tens column, a 0 in the hundreds column, an 8 in the thousandth column, making that 8,000, and a 1 in the 10,000th column, making it 18,000. So children should understand what's going on in this process at this point. Next slide. Okay, so moving to the end of primary school. So by the end of year 6, children should be able to work out multiplication either using the short multiplication method or the long multiplication method. And we'll also look at the box method in the next slide. So if we just have a look at the video which shows the long multiplication.
Hello everyone. In this video, we are going to look at the long multiplication method, multiplying two two-digit numbers together. I'm going to start by putting both numbers under each other in the tens and ones column. So the first step is to use the short multiplication method. So if we can imagine the 2 isn't there, I'm going to multiply 62 by 5. In brackets, I will write what we are doing. So 62 multiplied by 5. I'm going to start in the ones column. So 2 times 5 is 10. So I'm going to place the 0 in the ones column and carry the 1 to the tens column. The next step is to multiply 5 times 6, which is 30, plus the 1, which is 31. There are no more numbers to multiply, and I'm going to cross out the 1 just to avoid confusion later on. The next step in the calculation is to multiply 62 by 2. In brackets, I am going to write what we are doing. So 62 multiplied by 10, because I'm timesing it by the number in the tens column, and then multiplied by 2. Now, because I'm making this answer 10 times bigger, I need to put in the magic 0 in the ones column. Now that I've done that, I can carry on with the calculation. And I start again in the ones column. So 2 times 2 is 4. And 2 times 6 is 12. To finish off the calculation, I will add the two numbers together. So 0 plus 0 is 0, 1 plus 4 is 5, 3 plus 2 is 5, and I will place the 1 in the thousandth column. So my final answer to 62 multiplied by 25 is 1,550.
Okay, so another very different method is the box method of multiplication. So if we have a look at this example, we can see 428 multiplied by 111. So what we've done here is we've broken down the 428 into hundreds, tens and ones. So we've placed the 400, the 20 and the 8 at the top. And coming down vertically, we've broken down the 111. So we have 100, we have 10 and we have the 1. And then if you can imagine, it's been split up into boxes. we are going to find out what each individual answer is, and then we're going to add it up at the end. So if we look at the top left-hand corner, we can see 400 multiplied by 100 equals 40,000. Now, it's really important children know their times tables, and you can see how important it is now. So make sure the foundation is really good to begin with in the lower years. So once we've added all the numbers up together in orange, we can see that the final answer comes to 47,508, which would be the same answer as what we would get if we did the previous method in the previous slide. Okay, so now going on to division. So if we start with lower key stage 1, so that's years 1 and 2. If we look at the word problem, 10 sweets shared between 2 people, so the child should work out that that equals to 5 sweets per person. They should be able to form the link, so we can see here that 10 divided by 2 equals 5, or 5 multiplied by 2 equals 10, using the signs there, or they can use an array. So in this case, we have 10 symbols there for footballs. The child has then physically drawn out the 5 footballs in the 2 groups, and they've counted that in each group there's 5 footballs, and they then make the link that 10 divided by 2 equals 5. Okay, we're just going to have a look at another video on long division for Key Stage 2.
Hello everyone. In this video, we are going to be looking at long division. What is 384 divided by 16? I will write my calculation like this. Like in short division, we start on the left-hand side in the hundreds column and work our way down towards the ones column. In the first step, we can see that 16 does not go into 3, so we move across to the tens column and look at 38. So how many times does 16 go into 38? In the next step, we will need to use a bit of trial and error. Looking at the 16 times table, we know that 16 multiplied by 2 is 32, and 16 multiplied by 3 is 48. Therefore, the highest number of times 16 goes into 38 is 2 times. So we put a 2 over here in the tens column. We also write the 32 underneath, which represents 16 multiplied by 2. We can then subtract the 32 from 38. So 8 take away 2 is 6, and 3 take away 3 is 0. We then look at the 6, and we can see that 16 does not go into 6, and therefore we need to bring down the 4 into the ones column, which makes it 64. Next, we need to see how many times 16 goes into 64. Again, using trial and error, we need to work this out. We can use a more rounded number. In this instance, you may spot that 15 multiplied by 4 is 60, and 16 multiplied by 4 is 64. You should be able to work out that 16 goes into 64 4 times, and we can place the 4 next to the 2, making it 24. Therefore, 384 divided by 16 is 24.
Okay, so moving on to fractions now. Children should be able to recognise, find and name fractions such as 1/3, 1/4, 1/2 and 3/4. And this can be of any length, of a shape or a set of objects or a quantity. They should be able to write simple fractions, for example, 1/2 of 6 equals to 3, and also recognise the equivalents such as 2/4 and 1/2. Children should also be able to use number lines to reinforce the concept of fractions. Now, if we have a look at the number line here, we can see that each part has been divided into equal fractions, each representing 1/4. So children should be able to work their way across the number line and see 1/4, 1/2, 3/4 and a whole. And they should be able to recognise that fractions can go beyond 1. So we can go on to 1 1/4, 1 1/2, 1 3/4, and so on. Okay, so using and applying mathematics. Children should be able to represent their work using objects or pictures and discuss it, and they should be able to recognise a simple pattern or relationship. So if we have a look at this example, so question 1, a ladybird has 6 legs. How many legs do 3 ladybirds have? So the child has seen the picture of the ladybird there and counted the number of legs. They've then repeated that by drawing the ladybird 3 times, and then they've used the repeated addition method to work out that 6 plus 6 plus 6 is equal to 18 legs. Okay, and example 2, very different type of mathematical problem here. The child has been given a set of books, all of different sizes. They've been asked to order the set of books from smallest to largest. Now, the child here has not been given any measuring apparatus, so what they've used instead is reasoning. And they've done this by comparing 3 books at a time, and then ordering that from smallest to largest, and then repeated this using reasoning to find out, to make the length from smallest to largest. Knowledge, skills and understanding. So children should be taught the knowledge, skills and understanding through 3 main areas. Number 1 is through practical activities, and we'll have a look at some examples in the next slide, through exploration and through discussion. Any activity that encourages children to make connections between number work and any other aspects of their work in mathematics is always encouraged. So if we have a look now at some practical activities. So in the first example, we can see here a child has been given some building blocks, and in this case they're Lego blocks. Now you don't have to use Lego blocks, you can use anything that you find around the house. And if you look in the example, each Lego block has a different quantity of studs, so the round circles, which comes in very handy, especially during fractions. And then what you can do with the child is ask them to put them in order of size, count the studs, and then write the fraction next to it. So for example, the blue block there represents 1 whole, and then half of that, which would be 4 small studs, which would be half of the 8 studs, would represent a half. So they can physically see what a fraction looks like. You can make it more fun. Baking is always good in the kitchen, or if you can't bake, you can always use biscuits. And then you can ask the child to bake a cake and split the cake up between family members, or if they have friends around, or if you've got a family function, and ask them to split the cake up in half or in quarters, etc., and let them physically see what the fraction looks like, which will help enormously when working out mental maths as well. Okay, I'm just going to pass it over to Seema, who's going to explore a bit further on from there.
Thank you, Shalina. So we're going to take a look at how you can support your child's maths at home in a variety of ways. So as Shalina was just saying, that cooking and baking has very strong links to maths. As well as fractions, children are looking at measures, they're looking at the meaning of numbers in terms of that it holds a value for when you are having to measure ingredients. It also holds strong links to other areas of the curriculum, such as literacy, as children are needing to follow a recipe. It has links with art and DT as it's getting creative, that sort of thing. Unfortunately, at school, we don't really have enough time always to do as much cooking and baking as we would like to with the children, so it's a great idea to try and do lots of that at home with your child. Most of these activities are very varied in terms of they're not just related to number, they're also related to shape and measure as well, so try to take a look at all areas of the maths curriculum. Keep them very practical as well. As we've been saying, I think throughout the whole webinar, is that maths needs to be really practical, really hands-on for children to really develop a strong understanding of maths. I would say try to go outdoors for maths a lot. Again, we try to take the children outside a lot at schools, but it's not something there's always opportunities or even space for. So try to use your outdoor area, however big or small it is. use resources that you can get outside. So, for example, using stones to make arrays, or just counting stones if your child's very young, looking at door numbers and how the numbers go up or even go down, and what's the relationship between that. Just looking at numbers in the environment and what they exactly mean. It's important to go outdoors, and that children don't need to be sat at a table or a desk with a workbook. Yes, there is, you know, time for this. There are lovely workbooks out there, but I can't stress enough how important it is to be practical and go outside. In quick fire multiplication is a good one, because at the end of year 4 children have a government multiplication test where it's a time test where children are tested on their multiplication knowledge and recall. So quick fire multiplication is a really good one. All of these activities are very varied. They can be simplified or extended for whatever age your child is.
Thank you, Seema and Shalina. So much information there and lots of things for parents to take home. We have a few questions that have been put forward by the team. The first question is, my child is struggling with maths. How much extra work should I be doing with them?
I would say probably about 10 to 15 minutes per day. No more really, as children can, you know, sort of lose interest by then and you've undone all the work that you were doing in the first place. Try to keep whatever you're doing with your child varied. So if, for example, if you're looking at fractions, look at fractions in a variety of ways. Shalina gave us some great ideas with fractions. So try to look at fractions in a variety of ways to really deepen your child's understanding. And, you know, all children learn in different ways. So one way might help them more than another way. Try to keep it practical. If your child is struggling in an area with maths, keeping it practical, using resources is the best way to really support your child who's struggling to understand a concept. Lots of praise, develop their confidence in the area as well.
Thank you, Seema. Another question, what is the best way to help my child remember their times tables? Shalina?
Okay, so there's lots of different ways you can help your child remember their times tables. One really good way is to have a look on the internet. There's lots of YouTube videos out there that will help your child to sing along to times tables. You can print off lots of different worksheets. There's lots of good resources out there that you can use. You can also play games with your child. So, for example, you could use post-it notes. You could write out a question and then put the answer around the house and ask them to go and find the correct answer, maybe reward them when they get it right. And practicing really just verbally is a really good way as well. And I'd just like to stress, if there's anything to take away from multiplication and division, it is times tables, because if your child doesn't have a strong foundation at the beginning, they will struggle in other areas. So I would really prioritize your times tables. Yeah.
I would just like to add to that as Seema mentioned, by the end of year 4, the government has issued a new test where children will have to be tested on their times tables. So it is very important, as Shalina and Seema both mentioned, that they need to have a secure understanding of times tables to be able to do any other division work. Thank you. Next question is, how do I challenge my child if they are already fluent in number? Seema?
So here we're looking at developing your child's mastery skills. Mastery is a term that's used really widely in schools at the moment, and it's looking at number in different ways and just making sure that your child becomes a master of that concept and can really reason and have a deep understanding of it. So, for example, if your child knows very fast and accurately that 20 plus 5 is 25, you could perhaps use that as a foundation for what else your child knows. So, okay, if you know that 20 plus 5 is 25, what else do you know? Well, the child will then hopefully be looking at 200 plus 50 equals 250 based on the 20 plus 5. You could ask your child to create word problems, which is actually a very hard concept, to be able to create a word problem from a calculation already, and that will show you if your child has really and truly understands the calculation 20 plus 5, or whether it's just sort of rote learnt. You could promote your child to use inverse to check that their answer is correct, and that's when you're looking at subtraction to check your answer for addition. So 25, take away the 5 equals 20. Yep, the 25, the 5 and the 20 do work together. Get your child to discuss and reason how they do know that 20 plus 5 equals 25. Reasoning and discussing maths is extremely important. These days, maths isn't just about writing a number down on a page. Children need to have that deep understanding, which is called upon in SATs papers. You could ask your child to show you how to calculate 20 plus 5 in a variety of ways. So it could be using a number line, it could be drawing pictures. So maybe 20 lollipops plus 5 chocolate bars is 25 goodies. Even ask your child to show 20 plus 5 using the bar model that we looked at earlier as well.
Thank you. And the last question, should I be practicing SATs question with my child before they reach year 6? So if my child is in year 4, or should I be introducing them to these SATs questions?
I would say yes. I wouldn't necessarily go onto Google, download a year 6 SATs paper and give it to a year 4 child, but when you are looking at so for example multiplication, I would perhaps lay out a few multiplication questions in the same style as a SATs paper. It just helps your child to be used to seeing a SATs style question, and then when the SATs do come about, your child is more confident in answering a SAT style question, and it doesn't faze them, and they do have that sort of background in understanding and deciphering a SATs question, which can actually be quite hard to decipher sometimes. But I can't stress enough, just make sure that if you are doing that, it is a SAT style question that is to your child's level, and not just straight off of a year 6 SATs paper that you're giving to a year 3 or 4 child. Just use the style and that sort of thing.
Thank you very much, Seema and Shalina, for sharing your experience and your knowledge with us today. I'm sure that, and parents, we have a survey link over here. Please could you take your time to fill that out and let us know how you found our session today. As Seema and Shalina both mentioned, the videos that we have shared today will be available on the Head Start website, and as mentioned before, this webinar will be recorded, so you will be able to view it at a later date. I'd like to say thank you again for your time, and thank you for joining us today for our primary webinar. Thank you, Shalina and Seema. Yali Madet.